In this chapter, we're going to look at matrix solutions to linear systems of equations. So basically, we're going to be doing exactly the same thing we did in the previous chapter. We're going to be doing it, though, in a different way. And for those of you who have not seen a matrix before, all a matrix is it's a rectangular array, array of numbers. That's all it is, and you'll see here really quickly in this first example. So given this system, now we have three linear equations and three variables, x, y, and z. You can see a couple spots are missing, which just means this has plus 0y, and in this one there's no x term, so it would be 0 times x, and we need to remember that. Well, the corresponding matrix is just something that looks like this. All we're going to do is take the coefficients. We're not going to write x, y, or z at all. So the coefficients of the first row, 1, 2, 3. And then notice past the equal sign is the number 4. So I'm going to write 1, 2, 3, 4 on the first row. Okay, and by the way, the term augmented matrix basically means we have a vertical bar where on the left of the vertical bar is just the coefficient. It's called the coefficient matrix, basically. Just the coefficients of everything to the left of the equal signs. The coefficients of the three variables. And then this, you could think of this, maybe I'll even put an equal sign right there to match with that vertical bar. All right, the next one is going to be 5, and you must remember the 0, negative 1, negative 1. 5, 0, negative 1, negative 1. And then the third equation is 0x, so it's going to go 0, 12, negative 5, 8. That's all there is to creating an augmented matrix from a given system of equations. And by the way, this is how, the way you would enter it into a computer, if you were having a computer system solve these systems of equations for you, the computer doesn't care about x, y, and z. It knows that there are three variables, because how many columns are there to the left of the vertical bar? There's 1, 2, 3 columns. So you would simply enter it in a fashion more like this in order to solve the system of equations. So let's do it again with the next one, and you'll notice it's going to look a little bit different. Write the augmented matrix for this system of three linear equations. So the first row will be 1, 4, 3, negative 1. 1, 4, 3, negative 1. And the vertical bar again is kind of corresponds to the equal sign. And then we'll have a 0, 1, negative 2, negative 8. And then we get a 0, 0, 1, 3. Now, this is just another matrix in exactly the same format as this one. The numbers are a little bit different. As you can see, we have, let me raise this up just a little bit. This matrix right here is called in row echelon form, REF. And the reason it's in row echelon form is because the first non-zero element in each row is a 1, and it's called the pivot element. There's a pivot element for this, there's a pivot element in every row. Here, notice the first non-zero element is a 1. In this row, the first non-zero is a 1, and in the third row, the first non-zero is a 1. And the pivot element in each row falls to the right of the pivot elements above it. So this pivot element is to the right of this one. Go to the third row. This pivot element, that 1 there, is to the right of both of these. So you can see it kind of goes down into it. I guess that's just why they call it the echelon form. It's kind of a formation where you're stepping like that. You're going down and to the right. And then one more thing that doesn't apply to this one is if there were a row that was all zeros, it would have to be at the bottom. So we don't have one in this case. Now just one more comment about number 2. If I were to switch any two of those rows, it would no longer be in row echelon form. Now, hopefully that's easy to see. If you switch row 1 and 2, well then the pivot element would be here in row 1, and it'd be over here to the left in row 2. So if you switch any of these rows around, it would not still be in row echelon form. And before we end this video, just to do a little simple comparison between these two matrices. Look how nice this is. To solve for x, y, and z, well, to solve this one would take a few minutes, and this one would take a few minutes as well, not quite as long maybe, but you know one of the values already, don't we? Well, this is basically the x column and the y column and the z column. Don't we already know what z is? 0x plus 0y plus z. 1 times z is z. Z is equal to 3. So when you have one in this form, as it compared to this one, I don't know what any of the x, y, and z are by looking at this matrix. But at least with this one, I know that z, right off the bat, is equal to 3 because of row number 3. Okay, we'll get to that, more of that in the next video.